I have another set of questions here which we'd want to work out. So we're going to start with number 1. It goes, determine the center and radius of each of the following circles. So on A, we have x squared plus y squared plus 4x plus 8y minus 16 equal to 0. So we're going to start with part A. So this is what we have on part A. X squared plus y squared plus 4x plus 8y minus 16 equal to 0. Now there are two ways that we can find or determine the center and radius of the circle. Now the first method is when you first find the value of g, the value of f, and the value of c. Remember we said the equation of the circle, when it is given in the form x squared plus y squared plus 2gx plus 2fy plus c equal to 0. G is half of the coefficient of x. So the coefficient of x in this case is 4. So half of that is 2. And f is half of the coefficient of y, half of 8 in this case. So that's 4. And c is the constant, which is minus 16. So in such a case, the center of the circle is minus g and minus f. So that will be minus 2 and minus 4. So that's the center. And then for the radius, we use the formula square root of g squared plus f squared minus c. So in this case, this will be the square root of g squared, which is 2 squared, plus f squared minus c, which is minus 16. So minus and minus will give us plus, but let's just write it as minus of minus 16. So if we simplify this, this is going to give us square root of 4 plus 16 plus 16, which is the square root of 36. And it comes out as 6. So this is the radius. So we're saying the center of the circle is minus 2, 4, and the radius is 6. Now I want to show you another method. Remember from the previous working, we had the center coming out as minus 2, minus 4. And we also had the radius coming out as 6. So we want to see if we can also find the same answers using the second method. So the second method involves completing the square. We would want to express the equation in this form. So I'm going to rearrange here. So the x terms, I have x squared plus 4x. And for the y terms, I have y squared plus 8y. And that's minus 16. I'll take minus 16 to the right hand side. So I'll now be having equal to positive 16. I'll just add it to both sides. Now I'm going to complete the square starting with this pair. So that will be x plus half of the coefficient of x, that's 2, close bracket, squared, and I subtract the 2 squared. So I've just completed the square for these two terms. Then I'm going to complete the square again for y squared plus 8y. So that will be y plus half of the coefficient of y, that's 4 squared, and subtract the 4 squared equal to 16. So I'll now be having x plus 2 squared plus y plus 4 squared. Now minus 2 squared is minus 4. And if I add it to both sides, it means that I'll be having plus 4 here. And minus 4 squared is 16. If I add it to both sides, then I have plus 16 here. So I'm only left with x plus 2 squared and y plus 4 squared on the left side. So eventually we'll have the equation of the circle coming out as x plus 2 squared plus y plus 4 squared is equal to 16 plus 4, which is 20, plus 16, which is 36. So from this form of the equation of the circle, which I know you're familiar with, we can determine the center. That will be minus of 2 and minus of 4. So that's the center. And for the radius, it will be r squared, which is 36 here. So r squared is 36, which means r is the square root of 36. So the radius comes out as a 6. So that's the same answer we got with the other method. So you can choose which method is more convenient for you. But for part B and for part C, we are going to be using the first method. Let's go on to part B. So on part B, we have the equation 2x squared plus 2y squared plus 4x plus 8y minus 16 equal to 0. Whenever you have the equation of the circle in this form where the coefficients of x squared and y squared are not equal to 1, then you need to make them equal to 1 by dividing each term by 2. So I'm going to divide each of the term on the left side and on the right side by 2, so that it comes in the proper form of the equation of a circle in expanded form. So we have x squared plus y squared plus 2x plus 4y minus 8 is equal to 0. So I can now find the center and radius. So I'll need G, F, and C. For G, that's half of the coefficient of x. So half of 2 is 1. For F, that's half of the coefficient of y. So that's 2. Then C is the constant. So the center is minus G minus F. So that will be minus 1 and minus 2. So that's the center. And for the radius, that's square root of G squared plus F squared minus C. So this is going to give us the square root of 1 squared plus 2 squared minus 8. So that's the square root of 1 squared, that's 1, plus 2 squared, which is 4, plus, that's minus and minus gives us a plus, gives us 8. So 1 plus 4 is 5, 5 plus 8 is 13. So the radius should come out as the square root of 13. And that's the answer to part B. Let's go on to part C. On part C, we have x squared plus y squared minus 3x plus 1 equal to 0. So G here is half of the coefficient of x, which in this case is minus 3 over 2. F is half of the coefficient of y. We do not have any term in y, so that will be 0. Then for the constant, C is just going to be 1. Therefore, for the center of the circle, we will have minus G, which is just going to be 3 over 2, and minus F, which is just 0. Then for the radius, we'll just be having the square root of G squared. So G here is minus 3 over 2, so we square it, plus F squared, that's 0 squared, minus C, which is just minus 1. So simplifying, we are going to get minus 3 over 2 squared is 9 over 4. That's plus 0. Then minus 1. So we can just simplify this to 9 over 4 minus 1 will give us 5 over 4, which can be written as root 5 over root of 4, which is 2. So this is the exact value of the radius of the circle here. So we're done with part C. Now we'd want to move on to number 2. On number 2, a circle has AB as its diameter, where A is minus 2 and 3, and B has coordinates 6 and 9. Find the equation of the circle. Now, this is a very common question, and I'd want you to pay attention to how we can work it out. So we have a circle here, and we have a diameter here. The diameter is A and B, right? So the center should be at the middle here. I'll just call the center C. Okay, so according to the question, the point A and point B have non-coordinates. That's minus 2, 3 for A and 6, 9 for B. So we want to find the equation of the circle. Now, to find the equation of the circle, we will just need two things. We are going to need the coordinates of the center, and we're also going to need the radius of the circle here. If we can have the coordinates of the center and the radius of the circle, then we have the equation of the circle. Now, it's not going to be hard for us to find the center of the circle, because the center of the circle happens to be the midpoint of the line AB. And to find the midpoint, we'll go sum of the x coordinates, or the average of the x coordinates, that's minus 2 plus 6, divide that by 2. Then the average, or the of the y coordinates, 3 plus 9, then we divide it by 2. So we'll be having minus 2 plus 6, that's 4, so that's 4 over 2. Then 3 plus 9 is 12, so that's 12 over 2. So that's 2 and 6. So that's the center of the circle here. So we have 2, 6. Let's find the radius. For the radius, we can use the coordinates of the center. You see we got 2, 6. So we can use A and C to find the radius. That's the length of a line joining 2 points. So we're saying radius is equal to AC. And AC is actually the square root of minus 2 minus 2 squared plus 3 minus 6 squared. So this is going to give us the square root of minus 4 squared plus minus 3 squared. This can be simplified to 16 plus 9, which is the square root of 25, which is 5. So the radius is 5. So I'll put 5 here. Now that we have the center and radius of the circle, we can now find or write down the equation of the circle. So the equation of the circle will simply come out as x minus the x coordinate, so that's x minus 2 squared, plus y minus the y coordinate, that's y minus 6 all squared, is equal to r squared, that's the radius squared. So 5 squared is 25. So this here is the equation of the circle. And that's the answer to number 2. We can now go on to question number 3. On question number 3, it says, show that the point 1, 7 lies outside the circle with the equation x squared plus y squared plus 12x minus 2y plus 6 equal to 0. So we have a circle here with its own center, which I want to call C, and radius, which I would want to call R. And we have a point which we want to prove that it lies outside, so it's the point 1, 7. The equation of the circle is x squared plus y squared plus 12x minus 2y plus 6 equal to 0. G is 6, F is minus 1, and C is 6. So we want to find the center of the circle, and the center is simply minus 6 and 1. That's minus G and minus F. And as for the radius, that's square root of 6 squared plus minus 1 squared minus 6. This is going to give us 36 plus minus 1 squared, that's 1, and minus 6. So eventually we will get the radius as the square root of 36 plus 6 is the 36 plus 1, that's 37. 37 minus 6, that's 31. This is to 3 significant figures. We get 5.57. So we now have the center as minus 6, 1. And the radius is square root of 31, which we say it is 5.57 to 3 significant figures. So I'll remove this for now. Now that we have the center and radius, in order for us to determine where the point lies, whether it's inside or on the circumference or outside, we will need to find the length of the line that joins the center to the point. I'll call the point P. So we need to find the length PC. And to find the length PC, we use our formula for length of line. So we will use 1 minus minus 6, so that's 1 plus 6 squared, plus 7 minus 1 squared. So this is going to give us 1 plus 6, that's 7 squared, plus 7 minus 1, that's 6 squared. 7 squared is 49, 6 squared is 36. So we get the square root of 85, and the square root of 85 is 9.22 to 3 significant figures. So what is this telling us? It's proving to us that the point P of coordinates 1, 7 lies way outside of the circle, because if it were lying on the circle, then PC would have been equal to the radius, which is root of 31. If it were laying inside, then PC would have been less than the square root of 31. But since the length of the line PC is greater than the radius, we can therefore say it's shown. And that's how we answer this question. The last question is number 4. Show that the equation x squared plus y squared minus 2x minus 6y plus 45 is not an equation of a circle. So how do we prove that? We have x squared plus y squared minus 2x minus 6y plus 45 equal to 0. And we want to prove that it's not an equation of a circle. Now, we know that the equation of the circle should come in the form x squared plus y squared plus 2gx plus 2fy plus c equal to 0. And the condition there is g squared plus f squared minus c should be greater than 0. So it can not be an equation of a circle if g squared plus f squared minus c is not greater than 0. So I'll have to find g, f, and c first. G is half of the coefficient of x, so that's minus 1. F is minus 3, that's half of minus 6. And c is 45. So when I do g squared plus f squared minus c, I'm going to get minus 1 squared plus minus 3 squared minus 45. This is 1 plus 9 minus 45. 1 plus 9 is 10. 10 minus 45 is minus 35. So because g squared plus f squared minus c is coming out being less than 0, we can say hence it's not an equation of a circle. The reason being, for an equation of a circle, g squared plus f squared minus c should be greater than 0. And that's our answer to number 4.